so this is revision on probability. Okay, so a spinner has 8 equal sectors. Find the probability of spinning a 5. Now each sector, because there's 8 sectors, okay, each individual sector has a 1 in 8 chance of being picked. Now if you count the 5, it has 2 sectors. So spinning a 5 is going to be 2 sectors in 8, which is basically the same as 1/4. Okay, so just check this out. Answer number 1, a quarter. Okay, so that's alright. Next one, number 2. Not spinning a 5. Okay, so not spinning a 5 is basically 3/4, because 3/4 is not a 5. So 1 minus the probability of spinning a 5. So this is 1 minus the probability of a 5 is 1 minus a quarter, and that's going to get you 3/4. Okay, 3/4 there. You see the second answer is 3/4. Okay, third answer, spinning a 2. What we can see here is the 2 has 3 of them, so spin the 2 is 3/8. Okay, so 3/8, spin the 2, 3/8, correct. Okay, next one, number 4, spin the 7. If you're spinning the 7, we have, there's no 7s on the board, so it's going to be 0 out of 8, or 0. No chance of spinning the 7, because there's no 7 on the board. And finally, not spinning the 7. You're always not going to spin a 7, because every result here is not a 7, so the answer to that is going to be 1, a dead certainty. Okay, so give me a look, 0 and 1, that's perfect. Okay, so that's the first question done. Now, next question. Ben rolls the dice 300 times. How many times do you expect him to roll a 6? Now, if you roll the dice once, the chance of a 6 is a sixth, so 300 times, and every 1 in 6 times you're going to get a 6, so that will result in 50. Okay, so answer 1 should be 50. An even number is 300 times a half, because you're expecting half the times that you're going to get an even number, so 300 times a half is 150. Okay, so we're going for 50 and 150. 50 times and 150 times. So that's quite easy. Next question. One letter is chosen at random from the letters of the word dealing. Okay, notice that the word dealing, they're all different letters. Okay, find the probability that the letter chosen is a G. 1, 2, 3, 4, 5, 6, 7. So the probability the letter chosen G is 1 in 7. Find the probability that the letter chosen is a vowel or G. If it's a vowel or G, okay, so vowel or G, remember R means plus, alright, so it's the probability of the vowel plus the probability of the G. Okay, so probability of a vowel is 1, 2, 3, 3 in 7, and the probability of the G is 1 in 7, and that's going to give us 4 in 7. So 1 in 7 and 4 in 7 for question 3, 1 in 7 and 4 in 7. Okay, so we're okay so far. Next one. A bag contains 6 red beads, 4 blue beads, and 2 green beads. If a bead is drawn at random from the bag, what's the probability that it's green? So 6 plus 4 plus 2 is 12. Green beads is 2 and 12, which is 1/6. Blue beads is 4 and 12, which is a third. Green or blue is, remember, R means plus, so it's going to be probability of green, which is a 6, probability of blue, which is a third. A 6 plus a third is basically 6 plus a third is going to be a half. Okay, so 6th, a third, and a half for question 4. A 6th, a third, and a half. Okay, next one, not red. So if it's not red, what we're going to do is 1 minus the probability that it is red. And if it is red, there's a 1, 2, 3, 4, 5, 6, a half a chance of it being red. So 1 minus a half, and the answer therefore is a half. Okay, next one, question 5. There are 4 possible results in a fairground game. The table shows the probability of each result. Probability of top prize, consolation prize, your money back, and if you lose. Okay, what's the probability of getting your money back? Okay, remember, all the probabilities have to add up to 1. Okay, so it's going to be basically 1 minus a 20th minus a 10th minus 3/5. Okay, so you can just put that into your calculator if you want, and I'll just Okay, so just put all this into your calculator, and the answer we're going to get is 1/4. Okay, so 1/4. The probability of getting your money back is 1/4. Okay, so this is question 5, part 1, 1/4. Okay, next part. Okay, what is the most likely result? The most likely result is that you lose. Okay, because it's 3/5 of the entire thing. Okay, what's the probability of winning the top prize? The probability of winning the top prize, of not winning the top prize. So it's 1 minus the probability of top prize, okay, which is going to be 1 minus 1/20th, which is going to be 19 over 20. Okay, how many times would you expect to lose if you played 100 games? So multiply 100 games by the probability of losing, which is 3/5, and what you should get there is 60 times. Okay, so lose 19 out of 20 and 60 times. Okay, lose money 19 out of 20 and 60 times. So we're correct. Okay, now we're on to the next question. Okay, next question, question 6. James took a book from the shelf at random. The table shows the probability of getting different types of books. Okay, so you have fiction, paperbacks, sport, computers, animals. Okay, now what's the probability the book chosen will be a paperback? Okay, so we got to add all the paperbacks together. So add all these numbers together. Okay, so just going to add all them together. So 0.3 plus 0 plus 0.15 plus 0.1, and we should get 0.55. Okay, next one, a book about computers. Okay, so we're getting a book about computers. We got to add these two together. So a book about computers is going to be 0.25. Okay, if there are 120 books on the shelf together, how many of them are about animals? Okay, so if you add them together, okay, the books about animals are 0.1 and 0.05. Okay, so 0.1 plus 0.05, which is going to be 0.15. So that's the probability of getting an animal book. So if you multiply 120 by 0.15, what we'll get is how many animal books there is. Okay, so 120 multiplied by 0.15, and we get 18 animal books. Okay, so 18 animal books. So 0.55, 0.25, and 18. 11 out of 20 is 0.55, 1/4 is 0.25, and that's 18. Okay, so we're basically keeping our answers in a decimal form for the most part, or sorry, in fraction form. Okay, next one, number 7. A school snack bar consists of 4 snacks. The 4 snacks are burgers, pizza, pasta, and salads. Student can choose one of these 4 snacks. The table shows the probability that the student will choose burger or pizza or salad. Okay, so the first thing, all these have to add up. They have to choose one, so all this has to add up to 1. So to find out the probability of pasta, we're going to get 1 minus 0.35 minus 0.15, because it all has to add up to 1, minus 0.2. Okay, so just put that into your calculator. 1 minus 0.35 minus 0.15 minus 0.2, and what you'll get is 3 in 10, or 0.3. The probability of pasta is 0.3. Okay, now that that's done, what's asking us next is work out an estimate for the students who will choose pasta. So you have 300 students. Each student has a 0.3 chance, or a 3 in 10 chance of choosing pasta. So multiply 300 by 0.3, and what we're going to get is 90 students who will choose pasta. Okay, so 90 students. Okay, and that should be question 7. Question 7 is 90 students. Okay, next one. Question 8. Jane throws a red dice and a blue dice at the same time. Show all the possible outcomes in sample space. Okay, so to show the sample space, what we're going to do is we're just going to write down. Okay, so 1 is the first one. 1 2, 1 3, 1 4, 1 5, and 1 6. Okay, so the first dice gets 1, the second dice gets 1, the first dice gets 1, second dice gets 2. Now we gotta go again. Okay, so the next one is 2 1, 2 2, 2 3, 2 4, 2 5, Now you got to write down all the possibilities, okay? Now, what we know from the fundamental principle of counting is there's 6 outcomes from the first dice, there's 6 outcomes from the second dice. This means we're looking at 36 different outcomes, and we got to write out all 36 different outcomes. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 3 7, 3 3 7, excuse me. There is no 3 7. 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Next one, 5 1, 5 2, 5 on the first dice, 3 on the second dice, 5 on the first dice, 4 on the second dice, 5 5, 5 6, and finally 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. Okay, now that we've written out the sample space, okay, find the probability that Jane obtained a total of 10. Now the total of 10 is basically you got to find the first total of 10. You see why it's 6 and 4, and let's look at the diagonal. 6 and 4, 4 and 6, 5 and 5, and 6 and 4. So that is going to be 1, 2, 3. That's going to be 3 out of 36. Okay, so 3 out of 36. So 3 out of 36, which is a 12th. Now a total of 12. Only one of them makes a total of 12. The 6 and 6 here. So that's going to be 1 out of 36. Okay, so 1 out of 36. A total less than 6. Okay, so let's look at all the totals less than 6. Here's one here. 2, 3. These only add up to 4. Now less than 6 means it's not including 6. So we need numbers from 2, 3, 4, and 5. The first one is 2, the second one is 3, the third batch is 4, and the next batch is 5s. 4 and 1, 3 and 2, 2 and 3, 1 and 4. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 10 out of 36. And 10 out of 36 is basically 5 out of 18. Okay, 5 out of 18 for that one, okay? And now we'll just do this. So 5 out of 18 for that last one. Now, the same number on both dice. Now, the same number on both dice is basically this diagonal here, okay? You can see that the same number is on both dice all the way across here. Okay, so you can see that there's 6 of them. So 6 out of 36. Okay, so 6 out of 36, which is 1/6. Okay, so let's have a look. A 12th, a 36th, a 12th to 36, 5 over 18, and 1/6. A 12th, a 12th to 36, 5 over 18, and 1/6. Alright, that's perfect. Next one. Cleona picks 2 cards at random from the 3, 4, 5, and 6 of hearts. Find the probability that the sum of the numbers on the 2 cards is more than 9. Okay, so more than 9 is greater than 9. Let's write down the sample space, okay? You can have 3, 4. Now 2 cards are random. If you pick one card, you have a choice of 4 for the first card and a choice of 3 for the second card. This is 12 different outcomes. So let's write down all 12 different outcomes. 3, 4, 3, 5, 3, 6. Next one. 4, 3. 4, 5. 4, 6. Okay, next one. 5, 3. 5, 4. And 5, 6. And the one after that. 6, 3. 6, 4. And 6, 5. Okay, here's our 12 outcomes here. Let's label the ones that have more than 9. Okay, have more than 9 is going to be this one here. 6 and 4. 6 and 4. 5 and 6, and 6 and 5. So that's a grand total of 4 out of 12, which is going to get us a third. Okay, so a third for number 9. A third it is. Okay, next one. Number 10. 4 friends, Ava, Brian, Chloe, and Dara. Each write their name on a card, and the 4 cards are placed in a hat. Ava chooses 2 cards to decide who does the maths homework that night. List all the possible combinations. What is the probability that Chloe and Dara have to do the homework? Okay, so let's imagine the 4 cards. Okay, so we have Ava, Brian, Chloe, and Dara. Okay, so each one has a 1 in 4 chance of being or A, B, C, D, as you can see. All the names are, if you just to shorten them down to letters. Okay, so each one has a 1 in 4 chance of being picked. Okay, so 2 cards. So remember, if 2 cards are being picked, we're going to have to figure out how many combinations there is. So if there's 4 people who can be picked for the first position, then there's 3 people left. So there's going to be 12 combinations. Okay, so let's write down all 12 combinations. So we're going to go for AB, AC, AD, BA, BC, and BD. Then we're going to go for CA, CB, or CD. And then the last one is going to be DA, DB, or DC. So here's our 12 combinations, and we want to find out which 2 have list all the possible combinations done. What's the probability that Chloe and Dara CD or DC? Okay, so CD and DC, and that's going to be 2 out of 12, which is going to be 1/6. Okay, number 10 is 1/6. Okay, it's perfect. Okay, so next one. John picks 1 card at random and does not replace it. He then picks a second card. Okay, if the first card was 11, write down a probability that John selects an even number on the second draw. Okay, so imagine that 11 is out of the fray. Now all of a sudden we have 8 cards left. Okay, so 8 cards. 1, 2, 3, 4, 5, 6, 7, 8. How many of these are even? So that's 1, 2, 3, 4. So that's 4 and 8, which gives us a half. So the first answer is going to be a half. Okay, next one. If the first card was an 8, 8 is gone. Find the probability that he selects a number higher than 9 with the second draw. So a number higher than 9. So we only have 1, 2. We have a 2 and 8 chance to select a number higher than 9. So that's going to be a quarter. So a half and a quarter for the number 11. Perfect. Next question. In a small school, a class consists of children with a variety of ages in the given table. 3 5-year-old girls, 4 5-year-old boys, 6 6-year-old girls, 8 6-year-old boys, 5 7-year-old girls, 2 7-year-old boys. Okay, so let's add them all together, okay, and see what we get here, how many students we have in total. So we're going to add 3 plus 4 plus 6 plus 8 plus 5 plus 2. And what we get is 28. Okay, so 28 children in total. Now, what's the probability that's a 6-year-old boy? Okay, so 6-year-old boy is 8 out of 28. So 8 divided by 28 is 2 out of 7. A girl. Okay, so let's add up all the girls together. So the girls are going to be 3, 3, 6, and 5. Okay, so 3 plus 6 plus 5 is 14. So girls are going to be 14 out of 28, which is a half. Okay, a 6 or 7-year-old child. So 6 and 7-year-old childs is 6, 8, 5, and 2. So 6 plus 8 plus 5 plus 2 is 21. 21 out of 28, which is going to be 3 quarters. Next question. A boy or a boy or a 6-year-old child. Okay. Now, this is a tricky question because we have 6-year-old boys. So see, the or means a plus. Okay. Now, what we said was we know that half of them are girls, so we're going to add up all the boys. 4 plus 8. 4 plus 8 plus 2 is 14. So the probability of a boy is 14 out of 28. Okay. And the now the thing to remember about this is these events aren't mutually exclusive, okay? Because what we have is the probability of a boy, okay? The answer to boys comes from 4 plus 8 plus 2, okay? So that gives us 14 out of 28, or 6-year-old child. Now, 6-year-old child, okay, comes from the girls and the boys, but we've already counted the boy part already, so these 8 are already included in here. So all we're going to include is 6 out of 28. Basically, the events aren't mutually exclusive. There's an overlap because we can have 6-year-old boys. Okay, so if we're to do a Venn diagram, okay, what we'd have here is if you're to have a probability of this is the probability of a boy. This is the boys here. Okay, so out of the 14 boys, okay, what we're going to have is out of the 14 boys, 4 plus 2, 6 of them aren't 6 years old, and out of the 6-year-olds, okay, there's going to be 8 boys that are 6 years old, okay, and then in the middle over the other side, we're going to have 6-year-olds who aren't boys, okay, and they're going to be in here. So it's going to be 6 plus 8 plus 6, and that's going to get us 20 out of 28, or 5 out of 7. So that's a tricky question right there, okay. Next one. Aiden has a dice with 3 red faces, 2 blue faces, and 1 green face. He throws the dice 300 times. The results are seen below. What is the relative frequency of getting a red face? Okay. Okay, so the word relative frequency is just basically what's the probability of getting it. It's going to be 156 reds out of 300 times. So 156 divided by 300. And what we're going to get here is 0.52. Or some people might draw 13 out of 25. Okay, that's the relative frequency. Do you think this dice is fair? This dice is basically not fair, okay? You'd expect each result to be 100, okay? And basically, the blue side, Alan has a dice with 3 red faces, 2 blue faces, and 1 green face, okay? So we actually, wait a second, we have to see if this dice is actually fair. So the probability of getting a red face is 3 out of 6. So the probability of getting a red is actually 3 out of 6, which is a half. The probability of getting a blue, so the probability of getting a, sorry, let's do this again. I'll just use the different color. The probability of getting a red is 3 and 6, which is a half. The probability of getting a blue is 2 and 6, because 2 out of 6 faces. The dice has 6 faces, which is a third. And the probability of getting a green face is 1 in 6. Okay, and what we'd expect from each one is we expect the red faces to be a half multiplied by 300, which is 150. We'd expect the blue face to come up 100 times, and we expect the green face to come up 1/6 of the time, which is 300 multiplied by a sixth, which is going to be 50 times. So as you can see, they're all very close to each other's results, okay? So this one should be 50, this one should be 100, and this one should be 150. These results are really accurate, so the dice is very much fair, okay? So the dice is fair. Now, Emma has a dice with 4 red faces and 2 blue faces, okay? So if you're asked about the probability of getting a red face, the probability of getting a red face is 4 in 6, or 2/3. The probability of getting a blue is going to be, the probability of getting a blue is going to be 2 in 6, which is 1/3. Okay, she throws the dice 10 times and gets 2 reds. Say why the dice is not fair. Okay, so first of all, the dice is not fair because sorry, explain what the dice is not fair. If you throw it 10 times and you're meant to get reds 2/3 of the time, so you multiply 10 by 2/3. Alright, and what we get is we should get 6.67 reds, okay? So we should get 6.67 reds, which basically means we should have got 7 reds out of 10. We didn't get 7 reds, we only got 2 reds. So this shows that we only tossed the dice 10 times, and currently speaking, it's shown a high bias towards blues. We should have got 7 reds, and what we only got was 2 reds. Okay, so instead we're getting lots of blues. Now, Emma might be wrong because Emma maybe she didn't toss it enough. Okay, so maybe instead of tossing it 10 times, you can toss it like 1,000 times, and if it still shows a bias at 1,000 times, then it should be wrong. So if we were to toss it 1,000 times and we're going to get 2/3 of the time we're going to get a red, so 1,000 multiplied by 2 divided by 3, we'd be expecting around 667 reds. So basically Emma didn't have a big enough sample size. It's too small a sample size for Emma to make that judgment. Too small a sample size for Emma to make that judgment, okay? Next one. A coin is biased, so the probability of heads is 2/3, therefore the probability of tails is 1/3. Okay? Find the probability of obtaining tails on each of the first 2 throws. The probability of a tail followed by another tail is going to be 1/3 multiplied by 1/3, which is going to get us 1/9. Okay? And the probability of the first head on the 3rd throw, that would imply that we get tail, tail, head. So tail is 1/3, the second tail is 1/3, and the head must be 2/3, and that's going to get us 2/27. Okay, so 1/9 and 2/27. Okay, so we're happy with that. Next one, 15. Bag A contains 2 blue beads and 3 red beads. Okay, so in bag A, there's a probability of blue. The probability of blue is 2 in 5. The probability of blue is 2 in 5, and the probability of red is 3 in 5. The probability of red is going to be 3 in 5, okay? Now, for bag B, the probability of blue is going to be 3 in 9, which is basically 1/3, and the probability of red is going to be 6 in 9, which is 2/3. Okay. A bead is picked at random from each bag. Okay, draw 3 diagrams to show all the possible outcomes. Okay, so what we're going to do is we're going to have first bag. We either get red. Excuse me. First bag we either get red or blue, and then we're going to get the second bag, which is also red or blue. Okay, so see now what we get. So what we're going to say is this is bag A, and then bag B. Okay, so the outcome of bag A is going to be blue or red. So blue, red, and then you have a second outcome of blue or red. And then in this bag here we have blue or red. We got put in the probabilities. So the probability of the first bag is 2/5 for blue, 3/5 for red. The probability of the second one is 1/3 for blue, 2/3 for red, 1/3 for blue, or 2/3 for red. Now, the combinations for the answers are we could get blue, blue, we could get blue, red, red, blue, or red, red. To find out the probabilities of each one, you got to multiply the probabilities. So for blue, blue, it's going to be 2/5 multiplied by 1/3, which is going to be 2/15. The second one is blue, red, which is going to be 2/5 multiplied by 2/3, which is going to be 4/15. The next one is red, blue, which is 3/5 multiplied by 1/3, which is going to get us 1/5, or 3/15, if you wish. And then the probability of red, red is going to be 3 multiplied by 3 over 5 multiplied by 2 over 3, which is going to be 6 over 15, or also known as 6 over 15, or also known as 2/5. Okay, so let's add all these up together and make sure that they add up to 1. So 2/15 plus 4/15 is 6/15, plus 3/15 is 9/15, plus 6/15 is 15 out of 15. So the probabilities are more than likely correct. What's the probability that both discs are blue? It's going to be 2 out of 15 for that one. Find the probability that both discs are red. That's going to be 6 and 15, or 2 out of 5. Find the probability that both discs are the same color. So that's going to be 2 over 15 plus 6 over 15, and that's going to get us 8 over 15. Blue, blue, or red, red. And what's the probability that discs are of different colors? If they're of different colors, it's going to be 4/15. 4/15 plus 3/15, that gives us 7/15. Okay, so let's check our answers. 2 and 15, correct. 2 and 5, correct. 8 and 15, correct. And 7 and 15, correct. Okay, next one.